Is it enough evidence to support the claim that, and then we go back to what we're talking about. Support the claim that the percentage has changed since the poll came out. And then we just write the rest of it there. Okay. All right, so now let's go to the last example here at the bottom. So question 3 says, at a local In-N-Out, the average number of customers in a week was 634.43. The managers of the place want to that's kind of weird, want to see if it want to increase the percent. So wants to increase the price of a few items to compensate for the work needed. The manager believes that the number of customers will not be affected. He finds the test statistic is t equals negative 1.343 with alpha being 0.05. Find the no alternative, all that fun stuff itself, right, when it comes to it. Okay, now this time, since this is average, right, we're talking about mean, right? So that's the portion, that's our preparation. So first off, find all null and alternative hypothesis. Okay, so we're assuming it's going to be the same, so we're still assuming the average customers are going to be 634.43. Okay. Now he says, right, so the manager believes that the number of customers will not be affected. What does that mean? Okay. So that means it's going to be the same, correct? Not be affected, so it's going to be the same. So the opposite of being equal to is going to be not equal to 634.43. That's going to be our alternative hypothesis. Now again, if you're wondering why it's not equal to, again, right, by definition, the alternative hypothesis cannot have equality. It's going to be one of those three situations. It cannot have equal to. That's the null hypothesis. That's that portion there. So now we go on to step 2, is find our critical value. So since we're dealing with t-values, right, because we have mu, so this time we have a two-tailed test. So we're going to show you both sides of the t-value, so the t-values portion. Now here's the thing when it comes to a two-tailed test that we don't have to do for z-scores. Because we have a two-tailed test, both of these combined is equal to 0.05. So what's half of 0.05? 0.025. Okay, so that is the alpha we're going to be using to find the t-value, because that's the only, so this only happens when you have a two-tailed test. That's the only thing we have to do when it comes to a two-tailed test. Just like game of confidence intervals, we have to divide it by 2 because it's a two-tailed test. Okay, and degrees of freedom here, I don't think I told you how many. Oh, I don't think I did. Let's suppose n was 29, let's say, first. I forgot to write that. So therefore, degrees of freedom is going to be 28. Sorry about that. Okay. All right, so that 4, let's go back to using a t-value. So let's go to our t portion to find our critical value. So here is our t's. So alpha being 0.05 because we divided by 2. Going down to 28 degrees of freedom. So our t-value should be 2.048. Now remember, because we have a two-tailed test, we're shading both this one, so to get the one on the left, it's just a minus itself. And there we go. That's where we find the critical values. Okay. So here is our test stat, right? Negative 1.38. Now again, right, it doesn't have to be precise. All you care about is roughly where it's going to be. So I know it's going to be here, right? Somewhere between -1 and let's say 2. Right? Well, so the question is our test stat, so is our test stat in the regions? And it's a no, right? So because it's no, therefore we do not reject. Okay. All right, and then just like the last ones, just now we go to the conclusion. Right, so this one, however, let's go back to our conclusion. But the question is, does the original claim contain the condition of equality? So, we talked about this, right? That means not affect means equal to. So therefore, this is the first one that says the claim, which is right here, does have equality, right? Does not being affected means it's the same as that can happen. So this time, does the claim have equality? Yes. This is our first yes because of that. That's how it's going to be. So give you guys a hint. The claim is going to say not affected, is the same, equal to. All of those mean a yes when it comes to these ones. Okay, so it's going to be a yes, and now we go to reject or do not reject. So no, right? We do not reject. So we're in box 2. So for your conclusion, you're going to write, there is not sufficient evidence to warrant rejection of the claim that the number of customers will not be affected. Okay? And that's how you write the conclusion based off this information. Now, believe it or not, you're actually almost done with a complete hypothesis test. There's only one little snippet to complete fully how it's going to be, and that's just literally just finding this number. That's it. So you pretty much have 80% of a complete question down. So like I said, right, there's a lot more writing than there's actual mathematics behind this. So when it comes to these questions and on your quizzes and exams, there's going to be more, the whole part, is just like confidence interval, is writing a conclusion. If you don't write conclusions, you're going to get docked for that. So be very aware when it comes to write. So a complete hypothesis test is step 1, is getting these no alternative. Step 2, we'll talk about finding the test stat, analyzing, meaning this stuff and that stuff. And then step 3 is writing your conclusion down. So 3 steps to fully, just like a confidence interval, right, when it comes to doing that. Okay. All right, that's it for this section. This is a quick little section, or summary of everything. In the next sections, it's pretty much putting everything together. Figuring out this number, and then figuring out this number depending on what we're given to us, and basically putting everything together when it comes to it.